This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 6 of graphing trig functions. We're going to continue graphing sine functions, and we're going to do ones of this form: y equals a sine of x plus d. We've already done problems where we had something in the form like y equals 3 sine of x, so that would be like sine a would be 3 in this case. And we've also done ones like y equals the sine of x minus 2. And so now the question is, what if we try to put these two together? Y equals 3 sine of x minus 2. So that's what we're going to try doing now. So we want to graph y equals 3 sine of x minus 2. So first of all, we've got 3 is the coefficient of sine x. Remember, that has to do with the amplitude. All right, so let's write down what we know here. The period's still going to be 2 pi, because that's the period for just y equals sine of x. And the amplitude is 3. Remember, that's sort of like it's stretched. Now, the range is going to be a little bit different here. We'll see what happens. But if I were just going to do y equals 3 sine x, remember what happens? We multiply all these y values by 3, right? If we were just going to do sine of x minus 2, all the y values go down 2 spaces. We're going to do both of those things now. So the question is, what is 3 sine of x minus 2? Okay, well, I know what sine of x is, so I'm just going to plug that in. It's 3 times 0 minus 2, 3 times 1 minus 2, 3 times 0 minus 2, 3 times a negative 1 minus 2, and a 3 times 0 minus 2. Why does that make sense? Because we know if we plug in 0 for x, the sine of x is 0, so that's what I'm putting under here for the sine of x, 0. When x is pi over 2, I know the sine of pi over 2 is 1, so that's why I'm plugging in 1 for the sine of x, etc. So what you see here are the y values for each of the x values over here. So let's do those. We've got 0 minus 2, it's a negative 2. 3 minus 2 is 1. 0 minus 2 is negative 2. 3 times negative 1 is negative 3, and then subtract 2 from that, we're going to get negative 5. Then 3 times 0 minus 2 is 0 minus 2, or negative 2. So my ordered pairs here, and make sure you see your ordered pairs carefully, we've got 0, negative 2. Okay, so let's do that one. We've got 0, negative 2. I don't know why this says negative 2. There we go. Sorry. And this is supposed to be negative 2 pi. All right, so we've got that first order pair. Second order pair is going to be, I'll use a different highlighter. I'll use green. Pi over 2, 1. Okay. So we've got pi over 2, 1. It's right here. All right, so you see these ordered pairs? Then we've got pi negative 2. Right? So let's do that. Pi negative 2. And then we have 3 pi over 2 negative 5. So 3 pi over 2 all the way down at negative 5. Now I didn't draw this far enough, so you'd have to go down to negative 5. All the way down here. And then the last one, 2 pi negative 2. Back up here. All right, so what's happening is it's stretched just like the y equals 3 sine x. Remember, it goes up first and then down, but everything is shifted 2 units down from that minus 2. It's almost like if this were your x-axis, it would just look like y equals 3 sine of x. That's what some people do. They sort of put a dotted line, and then they pretend that's 0, 0. Go over 1 and up 3, etc. So they get those ordered pairs. But in any case, these are the actual ordered pairs you see over here. And you always want to make sure that's correct by plugging them in and seeing if it's true. Like in case you just kind of, when on autopilot it's easy to make a mistake, go ahead and actually put in 3 pi over 2 for x up here. You'd have 3 times the sine of 3 pi over 2. Actually compute it, and the sine of 3 pi over 2 is -1. Write 3 times -1 is -3 minus 2. That gives you -5. It's because it's easy to make a mistake here when you're kind of going quickly through these. And so this is one cycle. Now I can, of course, keep going. I'd have my other cycle. This would be going down here and then back up and up through here and down. So if I were going to do a sketch of another one, that's what it would look like. So that's the graph of, remember, this is the real x-axis, right? This dotted line is just for you to note it kind of looks like just the graph of y equals 3 sine of x if the x-axis was sort of transposed down here. So here's one for you to try. Graph y equals negative sine x plus 1. My hint is start off with what you know about x and just sine of x. Usually, we know the 0, pi over 2, pi, 3 pi over 2, 2 pi. And remember, it goes 0, 1, 0, -1, 0. So those are the order pairs we want to really have down pat. And so using this, see if you can figure out what the order pairs are and then graph it. So put the video on pause and try this on your own first. All right, so we want to do not sine of x, we want to do negative sine of x plus 1. So for the sine of x, we're going to look over here and see what we have in our y value here. So we've got -0 plus 1, which is just 1. We have -1 plus 1, which is just 0. We'd have -0 plus 1, which is 1. We've got negative 1, right? The opposite of -1 plus 1. All right, what's that? That's 1 plus 1, or 2. And we've got the -0 plus 1, which is 1. Hopefully you've noticed in all of these, like whatever you start at the top, the next 2 down will be the same, and then the 1 down below that will be the same. Remember? Because it kind of goes either down or down back to where it was, and then up back to where it was, etc. So let's graph these and check out again. The order pairs are 0 and 1 go together. Pi over 2, 0. Pi, 1. 3 pi over 2, 2. And 2 pi, 1, right? Those are our ordered pairs. So let's go ahead and graph those. Okay, we've got 0, 1. Pi over 2, 0. Pi, 1. 3 pi over 2, 2. It's up here. 2 pi, 1. All right, so notice it goes down first, right? And why does it go down first? Because of that minus sign, right? That minus sign means it's going to go down first. All right, so we could keep going here, get some more if you wanted to do 2 cycles. And it's always good to just check, something to make sure you just weren't on autopilot here and accidentally, made some arithmetic mistake, like put in pi. So in other words, what's y when you put in pi for x? So you'd have, negative the sine of pi plus 1. Okay, then you have to think, what's the sine of pi? Well, what's the y value over at pi? It's negative 1. I mean 0. Sorry, said that wrong. 0. And negative 0 plus 1 is 1, and that's exactly what I wrote here. Negative 0 plus 1 is 1. So at pi, it should be at 1, and yeah, I do have it up at 1. I always do a little double check. It's very easy to make a mistake. Okay, so there you have it, and that's how we do problems where we've got maybe a coefficient in front of the sine of x, then we're either adding or subtracting. And what you can see is what's really going on here is that the whole graph is shifted up 1, right, due to this plus 1, but the minus sign means it went down first, right? Now if it would have been negative 2, it would go down twice as fast, right? It would go down all the way down to here, right? So if that was a negative 2, it would still be going down, but it would like be really stretched out. So if I were doing y equals negative 2x plus 1, let's say it still was just up 1, it would start going down 2 spaces up through here and then all the way up through here and end up back here. So that would be 1 cycle of y equals negative 2x plus 1. So it's good to practice all these. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.